5, 4, 3, 2, 1. Hey there everyone, in today's video we're going to be doing a test of this emergency backup generator that is installed at this high school. This is a emergency generator installed to power all of the life safety and critical loads to keep the building safe for occupancy during a power failure condition. I'm going to explain some details and explanations on this system here, but if you guys are not interested in that and only want to watch the power failure test, make sure to skip to this point where we are going to be doing a real power outage failure test where we're going to hit both breakers that feed our two transfer switches here to simulate a full power loss. As far as all of the generator systems go, it's going to be just as if there's a power outage. This is a high school that was constructed in 2015 with an addition in 2018, a 3-floor, nearly about 200,000 square foot building. This school is also designed to be used as an emergency community shelter, and this school has a large atrium in it. Now, the reason that atrium is important because it is one of the main reasons a generator is required here. The atrium in this building goes for all 3 floors and has an open concept stairwells and walkways, bridges, so you need a smoke control system. During a fire, you still need to be able to use those open areas as a fire egress route. However, being that they aren't separated with walls or fire partitions, the smoke has to be controlled for safe evacuation, so we have these giant 600-volt smoke exhaust fans. I have a whole video on that system. It's pretty cool, but that system, because it's life safety, it has to work in a power outage. Here's a look at one of the 4 smoke exhaust fans that are mounted in this school, giving us a total capacity of 76,000 CFM, which is why we have this 600-volt emergency generator here. So this generator powers anything life safety. So it powers your emergency lighting. The only battery-powered emergency lighting is in this generator room here and the electrical room, and then the field house, which is a separate building at this building, does have battery-powered emergency lighting, but it is a detached building. It's a few hundred meters away, and it does not have any emergency power going to it, nor does the portable's regular lighting is also your emergency lighting, so whatever is deemed essential. So like this room, these lights are emergency power, your electrical room, and then bathrooms are, and then about half the corridor lighting is emergency lighting. Like every other light will be emergency lighting, and then specific lights in the large rooms like shops and kitchens, gymnasiums, and theaters will all have designated emergency fixtures in them. So some of those fixtures will be kept going on emergency power, as well as, like I mentioned, your smoke control system and your actual fire alarm system itself is on emergency power. This generator we are looking at here runs on diesel fuel. The fuel tank is down here. It's not a very large tank. It seems to get this generator about probably over 24 hours of use if I'd add up the time before it's empty. We use diesel and not natural gas for one very important reason, which is this building has to be a safe space in an earthquake or a seismic event if it's needed as a community shelter. This building is constructed to the earthquake standards that it is still going to be inhabitable after that event. There's different stages of seismic stability for buildings where some, once they are through an earthquake, they might still be standing, but they're not safe to be occupied. This building is built to still be able to be occupied after that event, like a hospital would be. However, in seismic movement, natural gas lines will shut down. Therefore, your emergency power source needs to be powered off of locally stored fuel, which diesel is. This generator puts out 72 amps at 600 volt, which isn't a lot, but it's enough for all your critical lighting and life safety systems. This building does not have the elevators powered in a power loss, which some are. That requires a much bigger generator, as that is a large load. This is powered by a 4-cylinder turbocharged diesel engine connected to this 600 volt generator head. I believe this is, let's see what this actually is. Here is the nameplate, 72 amps at 347/600. Don't know why it says 346, but whatever. 72 amps, 3-phase. This is your specs for your generator head here. It's meant to operate at 1800 RPM, 60 Hertz, and is a 75 kVA or 60 kW. The ventilation system, how that works here is this pulls in cool air from the outside. This is your radiator and your fan to pull air over the radiator. Here we have our two transfer switches, our emergency backup power and our life safety power. You are required to have those on their separate transfer switch. You have to have two. Any other standby loads have to be separate from your emergency critical transfer switch, which you can see that tech cable feeding. We have 40 amps going to our general backup power and 70 amps going to our life safety power. Your emergency backup power, which is the transfer switch on the left there, that is powering things like data and communication systems and any other more of a convenience item that keeps your servers going and all your internet gear, Wi-Fi, everything like that. But actually after this transfer switch, it goes through a big UPS first, but I'll show you that upstairs in the main electrical room. You can manually operate these with your isolation bars here, where you can shut off your required breakers, slide this over, turn on what you need. We can take a look at our generator controller here. You can see your generator frequency pickup right there, and your start delay is 3 seconds here. Warm up is 5 seconds. Thought it was actually 4, but 2-minute cool down delay. Could have sworn that was 4 seconds. Let's look at this one. Generator's ready. Auto exercise disabled. That's why we're here, to give it an exercise test. Fine.
I'm trying counties.
Yeah, so here you have a 4-second warm up. I'm going to set up a camera in here to watch the generator start, and I'm going to head up to our main electrical room where our main PDC is. Our generator room is that door right there, and here is our main electrical room. So here on our main switchgear, here is again your 70 amps feeding the emergency transfer switch, your 40 amps feeding your general backup loads. Service in this building is at 1200 amps, 347/600 volt. Right now we are loaded at, I know this always flashes on camera, 380, pretty low. So your panels with the red Lamelcoid label are your emergency panels. This one, EB, this is your backup power, non-life safety. And then here we have our life safety. So this is a 600 volt panel. You can see some of our smoke fans are supplied by it. This is at 600 volts, so it also goes through this transformer. And then here is your 120 volt 208 life safety. So anything 120, so lots of lighting. And then your lighting control relay panel with these modules that will basically override any human input and automatically switch your emergency lights to on, and will disable any inputs from switches, get rid of any control and override it, which this is the UPS right here. So this will cover the delay between the generator starting and transferring, so we'll never let the power go out to all of the data. This is the single line diagram here, which will show your transfer switches as well as the UPS. Here we can see our life safety one coming off of the main PDC, and your general backup power, transfer switches, and then what is fed off of them. There you can see some of the smoke control fans, UPS, transformers. With all that said, let's go ahead and cut the power to the generator and simulate a real power. So these are emergency lights in here. Every emergency light in the building will go out when the generator loses power and is waiting to start up. This will simulate just like would happen in a power outage. Anything that's not emergency power won't go out. So about half your lighting will drop out. Any emergency light will drop out until the generator starts, which you will see in this room. Okay, I'm going to start by shutting off the life safety so you can see the lights, and we'll have an easier judgment of how long it takes to start. I think it's around 12 seconds. 5, 4, 3, 2, 1. And we are on backup power. The fire alarm system will have some troubles. There they cleared, as it would have briefly lost power, and we would have had supervisories as well for your smoke control system losing power, as that is fully supervised. This is now running these lights in here, as well as every other emergency light in this building on generator power. So we'll go ahead and take a look at the generator running. I should also add, all lighting in stairwells is 24/7 lighting, and all lighting in stairwells is emergency power. It's no half of the lighting. Everything must be on emergency power. It's a little hard to hear me because this is pretty loud. I should have actually worn hearing protection, but I forgot, so I will limit my exposure to the sound. Here you can see utility power is lost, and we have no connection to utility power. So you can see that generator power is present, and our transfer switch is closed in, powered off of generator power, and that is going to our load. If we look at our life safety transfer switch, we are able to see the same status of the system right there. On the generator itself, you can see we are supplying load. We are in auto, putting out 345 volts. That is good. 25 amps at 600 volts. We can see our temperature and our frequency, which is at 61.1. Bouncing around 60 hertz, that's real good. We're right on the frequency we should be. This damper here has opened. We also have this damper here, which today it is closed, you can see. However, I've also seen it open. I have not had training on this. I'm not sure what the deal is with this. However, this seems to open and sometimes be closed. I'm wondering if it's depending on temperature. Today it's -2 degrees outside, but I'm not sure if that has any impact on the room temperature and if this is open or not open. This is on the outside here. Here is that louver that is ducted to our radiator, and this is our exhaust up here. this is pushing air out of the room, and this is also your exhaust going out, and here is where your air is being pulled in. So that generator is supplying emergency power to all of your stairwells. This school has, let me think, 1, 2, 3, 4, 5, 6 stairwells that are powered fully off generator power. It's all emergency power source, and the corridors are about 50%. We'll give it a little bit to warm, get up the temperature, 10-15 minutes or so. This is a real test. We are simulating a power outage. Some will just hit the start button. I do not consider that a test, as I have seen generators that will start fine, but then fail to transfer load over. So I don't think that's a very good test. You can also use the exercise test on the transfer switch that will transfer load. That is a good option. It limits the downtime of power and still applies load to the generator. Because you don't want to test a generator without load, because the diesels can get wet stacking if they are ran without load on them. I've heard that newer diesels don't suffer from that as much as older ones, but it's good to let it get some load on it. We'll head in now. It's cold out here. We're now going to restore power to the transfer switches, where it will then enter a utility check delay to make sure that utility voltage is stable, that utility power source is a reliable source to transfer back to, because there's no point of switching back over if your power is just going to go out again. So it's going to wait about 2 minutes, I believe it's 2 minutes on this system here, before transferring back to utility, and it will then enter a cool down period where it will run the generator without any load on it. That is really important, especially with a turbocharged diesel, as you do not want to shut down a generator that potentially was just running at 100% load for hours, and that turbo is almost red hot. You don't want to shut that down, as that's how you can seize parts. So you want to give it some time to run without load to just cool down with the engine running. So that utility power is now present at the transfer switch, and now we will enter a waiting period before transferring the load. You will see that load transfer as all the lights will drop out. It's not an instant switchover. There is a load break, which is important for any equipment, especially large motors, that you don't want your frequency to all of a sudden just change. You will have large inrush currents as well as huge changes in the torque of that motor. It's not good for stuff like that. There we go. We are back on utility power. You may have heard the UPS click first. That transfer switch is what I restored its power source to first, so that ran to a couple seconds sooner. We'll close these panels back up here. The generator is now in its cool down period, so we can take a look at it and You will see our transfer switches will have both power sources present, but will be closed in on utility power. Looking at our transfer switch, you can see we do have both power sources present, there and there, but the green light on the left side, this guy, means that that's the source we are closed in on. No amperage, that's good. And there we shut down, and this damper is closing. I think it could go a little further. There you go. This generator is fully monitored by the fire alarm system. Should there be any problem with this, such as low fuel, low temperature, or any issues with this, it will put a supervisory on the fire alarm system saying that there's a problem with the generator. There is also a module up there from the fire alarm system, which this generator is supposed to create a supervisory when it is running and the building's powered off it. However, I haven't had that on either of the previous tests I've done. So something's either gone wrong with that, or there's something else I don't know about, where there's something tied off of utility power where it'll only create that if utility power is lost. I'm not sure if there's something else in line there that is creating that condition to not come through. Not all of our schools have this, just schools that were constructed more recently. Pretty much any new school will be constructed with a generator, as it does save on maintenance as far as emergency lighting goes over time. Won't share any exact numbers, but some of our schools, some of our larger schools that do a battery backup emergency lighting, they cost us a lot of money in maintenance of replacing those batteries every 3 to 5 years. A lot of money. More money than we've spent refilling or hiring somebody to maintain and do the annual test of this generator. That is for sure. So the generator does have a high upfront cost, but not only it's needed in some buildings because there's some emergency systems you just can't power off batteries, such as smoke control, but it also gives longer time during a power outage before it's going to run out, as this can just be refilled and refilled and refilled. So when your power outage occurs, you know you have at least 24 hours in the tank of it, assuming it's kept full, and that is much longer that you can operate your building for than the 30 minutes that battery emergency lights go, which you aren't even supposed to occupy the building. You're supposed to actually leave the building. That 30 minutes is just supposed to be enough to get you out, not stay in the building that a lot of people think it is. So not only it's legally required for this building, in the long run of this building, say the school is here for another 60 years, this will save money, and this generator, for the amount of use that it gets, this will outlast the building and will go for way past the building's useful life. Most likely, depends. We'll see. If things go really bad and power outages become much more common and this is relied on more, then probably not, but I can't see that happening. So guys, that's going to be it for this video. If you've enjoyed this one, make sure to give it a thumbs up. If you do have any comments or questions, feel free to leave those down in the comment section. And if you do enjoy my channel, make sure to subscribe. Also, if you are interested, I do have an Instagram account at Pickle700 for bonus content, stuff posted earlier than you'd see it on the YouTube channel, that sort of thing. Alrighty guys, thanks for watching.